I'm Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about the computer network subject, in which the topic is congestion control algorithms. The outcome of the congestion control algorithm is the congestion control algorithms are optimizing the bandwidth utilization. That is, the data transmission bandwidth utilization can be optimized. That means now which is giving the guarantee the efficient use of the network or the resources now without overloading and reducing the packet losses. That means now minimizes the dropped packets by managing the data flow during the congestions. These algorithms, the congestion control algorithms, now which is improving the throughput. Throughput means now per second number of the packets can be transmitted. How many number of the packets can be transmitted per second? That is the throughput, which will be the increased. The number of data packet transmission rate can be increased. That is improved throughput. And maximizing the amount of the data successfully, which will be transmitted over the network. Next, the outcome is now the latency can be minimized and the jitter and latency can be minimized. Latency means now time delay, reducing the time delay from source to destination data transparency, reduce the delay and variations. Jitter means now time variations, reducing the time variations in a packet delivery to the destination. Within a time will be delivered with this the congestion the control algorithm. Now within the time the data packets can be delivered to the other destinations, improving the real-time application of the performance. So these are all the outcomes of the congestion control algorithms. What is a congestion control? Generally the congestion means now overloading. When will happen this the congestion means whenever the data is overloaded comparing then the capacity of the network. Suppose here if the capacity of the network, if we take this is the network now, the data is overloaded, then the capacity of the network, then only the congestion will be occurred. Further now controlling these are the congestions. So we are utilizing the controlling algorithm. That is a congestion controlling algorithms can be utilized. For example, here if at a time Wi-Fi the server, if at a time now more than number of other users are requesting the Wi-Fi services, Wi-Fi the speed will be decreased. That means overloaded. Whenever the more number of users are increases, so it will be the overloaded utilization. Whenever the utilization is the overloaded, the congestion will occur. Now for that avoiding that the congestion, the controlling algorithms, the congestion the controlling the algorithms can be utilized by using this the congestion the controlling algorithm. That the congestion the overloading the mechanisms now that will be decreased. Here is critical mechanisms that congestion control algorithms are the very critical the mechanisms in a computer the networks. Now. So these mechanisms, congestion controlling the mechanisms now, which is regulating the data transmission rate between the source and the destination. That means now fixed data transmissions can be transferred between the source and destination. That is controlling the data transmission rate and ensuring the network stability and performance. Here is the network stability. Whatever the capacity is there, the network capacity, based on this the capacity, now data transmissions can be done and improving enhancing the stability of the network and automatically improve the performance of the network. Here is the congestions are arised here. Why? Because now more than one packets. So which is the transferring. That means now overloaded, the packets are overloaded. Number of the packets are transferring here. So these are the number of the packet that the transferring is overloaded. Now which is the packets are the transferring here at this the particular node or at this the particular router. So more than that router capacity. So whenever the more than this the router the capacity here, immediately on this the network the congestion will be arised. So the aim of this the congestion the control algorithm is the preventing or mitigating the congestions, reducing the other congestions. How it is reducing the other congestions? That means now by managing the rate at which now the data packets are sent. Whatever the data packets are sent, that is reducing the data rate the transmissions can be reduced. So this router now based on this the capacity of this router. So that many of the packets can be transferred to this particular other router. So like this now the congestion can be controlled. And congestion controlling generally by using this the two mechanisms. So that is the two techniques now we are using to controlling this the congestion. The two techniques of this the congestion the controlling is the open loop the congestion control the technique. Another one is a closed loop congestion the control the technique. These are the two techniques. Utilizing these the two techniques, congestions can be the control. So used to controlling or preventing the congestions. Congestion the control the techniques can be broadly classified into these two categories. Here is open loop the congestion control. Open loop the congestion control. So here is now congestions can be controlled by following different policies, applying the different policies. By applying this and the different policies in a open loop, the congestions can be prevented or controlled. Generally, here in a open loop, the congestion can be controlled before it is happening. Before happening the congestion, now the congestions can be controlled over the network. Before happening this the congestion over the network, now it will be the control. The congestions can be controlled. The congestion control is handled either by the source or the destination. It will be handled by the source the station or the destination station based on this the congestion, the type of this the congestion, and that will be controlled and re-sending the data. Here the policies for the for congestion control in a open loop means now first the policy is a retransmission policy. That means if any the source station, if it is transmitted the source station any data to the destination the station here, suppose if it is not reach any acknowledgement, that means if any data packets are lost, so the retransmission the policy, applying the retransmission policy, again resending the data from source to the destination. Any packet loss, any data losses, or any acknowledgement not received. So in this the case now, generally this retransmission policy can be applied. Window policies, selective based approach. Now window selective based approach. Now this is the window policy can be applied and controlling the congestions. And discarding policies and other acknowledgement policies, admission policies. These other policies can be applied over while occurring the other congestions over the network. These the policies can be applied. By applying these the policies now, the congestions can be controlled and transmitting the data to the destinations without other congestions. That means exact whatever the destination is expecting, the exact data can be transferred. With this the following, with this these are the policies. By following these are the policies. The policies now which is adapted by the open loop congestion control. Here is first one is a transmission policy. Transmission the policy. So it is this is the policy now which is retransmitting of the data packets. That means now when it is retransmitting the data packets means now whenever the sender feels the packet is lost or corrupted. So whenever the sender is the field packets are lost or packets are corrupted, packets are congested, isn't it? Then only these retransmission policies they can be applied and retransmitting the same data packet to the other destinations. The data packets need to be transmitted here. If it is data packets are lost between source and destination, here is the data packet can be retransmitted again here. This is the retransmission. This retransmission may increasing the congestion in a network. Here is congestion in a network here. Why? Because now overload will be occur. Whenever now retransmission number of retransmissions now we are going to transmitting, network overload will be increases. That means the network overload. That means congestions will be whenever the network overload is occur, the congestions will be arise. So more than this, the capacity of the network now, if you transfer the data, so more than the capacity of this the network now, generally these the congestions will be arise. Now which is preventing the congestions and the retransmissions, the timer must be designed to preventing the other congestions. Now it is to preventing this other retransmissions is prevent the other congestions. And which is also now which is optimizing the efficiency of the data transfer between the source and destinations. This is the retransmission of the policies. And window policies. Window policy, so which affects the other congestions. Now already here which is when this window policies can be applied means whenever the congestion is occurred. So which affects the other congestions now. So that means several packets in a go back in window or resend. Window policies means go back window. So here this technique can be utilized. Go back window technique and or resending these other packets. Some of the other packets may be received successfully at the receiver side. So some of the other packets now, whatever the packets are sending, it will be received successfully at the receiver other sides. This means now the duplicate packets, whatever the packets now we are sending, the duplicate packets now may increase the other congestions. If it is any duplicate packets over the network, if you are transmitting, so we increasing the other congestions in this other network and make it the worst other. That means now here is we are applying the window by applying this the window other policy. Selective repeat window should be adapted. That is a go back window protocol. Now we are using the go back window protocol. By using this go back window protocol, wherever the congestion is arised immediately. So with the help of this go back window protocol, now acknowledgement can be sent to the source. So with this the go back window protocol now, which will be identified the congestion is occurred, and selectively repeat the window. So by repeating that the window of the packet, now that will be transmitted. It will be adapted to sending the specific packet. Whatever the packet is lost, whatever the data packets are lost, that will be selective that loss of the data packet and recently transmitting that other data packet to the destination. May have been lost. Now whatever this the packets are lost, that the packet lost the packets can be same packets can be sent by the source station to the destination station by applying this window policies, and also discarding policy. Discarding policy means now it is a discarding of the good policy which will be adapted by the router. That means if any packets are damaged packets, so by the router now it will be discarded. That means removing the other packets. Whatever the packets are leading to the other congestions now, so those other packets can be removed. That is a discarding other policy. So that the source may preventing the other congestions. At the same partially discarding the corrupted or less the sensitive packets. Here is main the corrupted packets. If is there any corrupted packets or less the sensitive packets now, that corrupted packets or less of the sensitive packets will be discarded. So by discarding these the packets now, so load will be decreased. Load over the network now, the overload will be the decreases and data will be effectively transferred. Also be able to maintaining the quality of messages by removing these the corrupted or less sensitive the packages now. The quality automatically will be improved. In case of the audio file transmissions, routers can discard the less of the sensitives. Less of the sensitives now, the packets, less sensitive packets will be discarded, and preventing the congestions, also maintaining the quality of the audio of the files. So these are discarding of the policy can be applied. This is the discarding policy, and by applying this the discarding policy, conditions can be controlled here. Acknowledgements or policy. Generally, acknowledgement the receiver here, once the data is received by the receiver which is sending the acknowledgement, if it is successfully receives the data, now acknowledgement can be sent to the sender. So this is the acknowledgement of the policies. By acknowledgement, these are the policies. Now the sender now, which is confirmed that the data will be received successfully to the other destinations. That means these acknowledgement of the policies also the part of the load of in a network. Here, the part of the load of the other networks. Now the acknowledgement of the policies now, which is the imposed by the receiver, may also affect the other congestions. Here is the receiver should send the acknowledgement for the n packets. Sending the acknowledgement for the n packets rather than sending the acknowledgement for a single packets. Sending a single packet now, the receiver should send acknowledgement only if it has to sending the packet or time is expired. Here is, if it is acknowledgement sending the acknowledgement, the receiver sends the acknowledgement, data is received, or time is expired, or within jitter, the time is varies. The packet receiving time is the varies, the jitter, the delayed. So that means that the latencies can be replied by the receiver. So this is all these are the things now, the jitters, the delay, and the time expires. So all these are the things will be considered in the acknowledgement of the policies. And the admission control policies. Admission control policies means now entering into the network. Here is data. We have to enter the data into the network. Here the controlling. So whatever the capacity of this the network now, based on this the capacity of this the network now, that much of this router now, which is sending this packet, which is ensure specific volume of a traffic, is admitted to the network based on the capacity of the network. Capacity of the network here. So it will be sending the data packets. So this is admission as a control. Now admitting the packets into the network for transmitting to the other destination. So that's why here we have to consider of this the network the bandwidth. What is the available bandwidth of the network? So these are the factors now we have to consider, and also admission as a controller can be included. Here is the admission as a controller now. So which is checking the capacity of the network. So load of the network now, based on that load of whatever the load which is vary this the network now, that much of the data packets can be delivered to the network, transmit to the other network. Remaining data packets can be make in a hold. Once the space is available here, once the capacity below that the capacity is occurred here, immediately whatever the waiting packets is there, that waiting packets can be sent, transferred to the networks. That is a buffer of the occupancy. That means that can be stored. Waiting packets can be stored in a buffer. Once if it is available, the capacity is low capacity is occurred here, immediately the buffer whatever the packets are stored in a buffer, so that the packets can be transferred to the transfer over the network. So this is the admission control to the network. So if there is the chance of the congestion, there is the congestion in the network, router should deny the establishing the virtual network connections. Why? Because now, which is preventing the further congestions. That is all these are the policies. or adapted to preventing the other congestions before it happened in a network. That is a open loop congestion. So we are saying it as a open loop other congestions. Open loop congestion technique is nothing but so controlling the other congestion before it happens. Before congestion is happened, so that the congestions that can be controlled by the open loop other techniques. The congestion control now, which ensures that the network can handle the traffic very efficiently without other data loss in a open loop condition, open loop techniques. Here is next technique is a closed loop congestion control technique. So closed loop the congestion control techniques now, so which is applied, which is removing the congestions after happening the other congestions, after it happens. In a open loop congestions, removing the controlling this other congestion before it is happening, before congestion is happening. But in a closed loop other congestion now, removing the other congestions, overload will be removed. Once the overload is suppose if you are not remove the overload, the speed will be decreased, access speed will be decreased. The best example is server accessing. The multiple users are accessing the server more than this the capacity of this the server. Now the speed will be the decreases. That is a cause of the other congestions. Congestion will occur here. Here there is a closed loops now. The congestions will be removed. These are the controlling techniques now. Congestions will be removed after it happens, after happening the other congestions. Several techniques are used by the different protocols. Here is the some of these other techniques are back pressure other technique, choke packet other technique, and implicit signaling technique or explicit signaling technique. So by using these other techniques now in a closed loop, whatever the congestions are occurred, that the congestions can be removed in a closed loop. See, back pressure. Back pressure, so it is a technique in which now the congested node stopping the receiving packets from the upstreaming node. That means here node 3, at node 3 the congestion will arise. Once whenever the congestion is arised at a node 3, immediately now back pressure, which is apply the back pressure, and by applying this at the back pressure now stop the receivings from the upstreaming nodes. So node 2, node 1 are these two nodes are the upstreaming nodes. These two are the upstreaming nodes. Upstreaming. So these two are the upstreaming nodes, and node 4. Node 4 is a downstreaming node. Downstreaming node. Data can be transferred from source to destination. That means from the upstreaming node to the downstreaming node. Here is once the congestion is occurred, immediately back pressure can be applied to the upstreaming nodes. Whenever the back pressure is applied to the upstreaming node now, immediately which is stopping the data flow. The data packet flow can be stopped. So which is indicate to the source now, the congestion will be back pressure now, which indicates the congestion is arised and so on, so the node here. That's why, so the data cannot be moved to the other forward. So this is a back pressure. That means this may cause the upstreaming node or nodes to become the congested and rejected the receiving data from the above nodes. Above nodes means now that above nodes we are saying it as a upstreaming nodes. Upstreaming nodes now, which is reject the data receiving from the transferring from the upstreaming nodes. Back pressure is a node to node the congestion control technique. Here is a node to node. So back pressure it is nothing but it is a node to node. Node to node the congestion the control technique now that propagate in these the opposite directions of the data flow. Here is so this is the congestion the control of the controlling by using the back the pressure. This the back the pressure can be applied only to virtual circuits only, where each node has informed to its above upstreaming node once the congestion is arised. So in this diagram, if you see, third node is a congested node. The congestion is arised now, which is tapping the stops the receiving data packets. As a result, the second node may get the congested. Now, whenever the back pressure, so second node may be the congested to slowing down of the output data flow. Data flow can be slowing down from node 1 to node 2, node 2 to the node 3 whenever the congestion is occurred at node 3. Similarly, the first node may also get congested and informed to the source to slow down. That means no source will be the slow down to sending the data packets. So this is the back pressure. So by slowing this data, the data flow controlling can be done. That is a back pressure technique. Choke packet technique. Choke packet technique also is applicable for the both virtual network as well as the datagram networks. So virtual network or the datagram networks. So for both now, this choke packet the techniques can be applicable. So in a choke packet now, wherever the congestion is occurred, that means a choke packet is a packet. So sent by the node to the source to informing its a congestion is occurred. That means here at third node, the congestion is occurred. Now once the congestion is occurred here, directly which is sending to the choke packet to the source. It is not sending, the congestion, the choke packet is not sending to the node 2 and node 1. That means second node and first node it is not sending. The choke packet now which is sending direct to the source station. Which is indicating the congestion is occurred at so and so node. That means the delay, the latency will be decreased here by sending the choke packet here. That means the direct sending to the by sending the direct to the source station, the time delay is decreasing the time delay. So which is not sending the upstreaming nodes, direct sending to the source node. And like this now, the congestions can be controlled with help of the choke packet as the technique also. Each the router here now which is monitoring its resources and utilizing at each of its output lines. Output now, whatever the output lines now, it will be monitored and utilized here. Whenever the resource or the utilization now which exceeds the threshold value which is set by the administrator. Now threshold value is set by the administrator. So that's why the router is which is directing sends a choke packet to the source, which is giving the directions whenever the congestion is occurred here. By default now, this router directly sending the choke packet to the source. So by sending if it is sending the choke packet means now which is giving the feedback, giving the feedback to reducing the traffic flow. Choke packet sending choke packet to the direct source means now immediately whenever it is received, the sender receives the feedback. Now immediately feedback of the packet is received immediately, so which is reducing the data flow or data traffic will be reduced. The intermediate are the nodes through which the packets has traveled are not warned about the congestions. Via the intermediate now nodes now the packet will be transferred and so which is not warned about these other congestions. And implicit the signaling. So in a implicit signaling, so there is no communication between the congested node and the source node. So this is the implicit signaling. There is no communication to congested node and source node. That means now, if it is no other communication means now here is the source node is guessing that there is the congestion is occurred in a network. So within this other time, acknowledgement is not received within a time or within the latency. If it is a latency is occurred while receiving this acknowledgement now, so immediately, so which is the source guesses. So the loss is the packet is lost. Packet is not received by the receiver. It will be guessed by guessing this by guessing here now, which is transmitting the packets. For example, now when the sender sends the several packets, sending the several packets, so there is no acknowledgement received. For this, whatever the packets are sending, there is no acknowledgement is received. That means now which is the source mission now which is assumes that now there is the congestion is occurred in between the source and the destination. So this is a implicit signaling. Assumption is nothing but a no acknowledgement due to the no acknowledgement receiving from the receiver. The assumption, source assumption of the congestion is causes. That is a implicit signaling. Here is explicit signaling. In explicit signaling now, what will happen means now, if a node they experience the congestion, it can explicitly sending the packet to the source or destination. Source which is sending the packets to the source or destination to inform about the congestions. Now here is explicitly now, so it can explicitly sending the packets to the source or sending the packets to the destination if a node experiences the congestions. It informing about the congestions to the source and informing about the congestions about the destination. That means here the difference between the choke packets and explicit signal is that the signal is included in the packet. Here is now explicit packet, now the signal will be included along with the data. But in a choke packet now the signals are not including. Choke packet, whenever the source is receiving the choke packet now, which is assumed it as the congestion is occurred. But here in explicit signaling now, along with this the data packets now, so which is sending the signals as the feedback. That is congestion signals can be the sent that carry the data rather than creating the different packets. So this is in case of the choke packet techniques. Choke packet here no signals. We are not sending the signals in a choke packet technique, but in explicit signaling now we are sending the signaling about the congestions. Here is now the best example is a disasters. Then that means any signaling is a fail in a railways. The best example is a railways. Generally, it is using in a railways now. If any signal is a failed, immediately the explicit the signal is sending the along with the location, whereas where the trains are disastered now. So this is the real time the application. The explicit signaling can be utilized there. Here and explicit the signaling can occur in either forward or backward the directions. Here is this can be applied in the forward directions or backward directions. Now forward direction means now signaling. So in a forward direction, the signal sent in a sent in the direction of the congestions. Here wherever the congestions are occurred, direction of the congestions now signals will be sent. The destination is warned about the other congestions. Now here it is warned about the other congestions. Overloaded. So whatever the data is transmitted, so more than that means no the data transmission rate is overloaded. The receiver in this is the case now which adopt the policies, but different the policies by applying these congestion control mechanism of the techniques or mechanism of the policies now to preventing the further the congestions. Backward the signaling. In a backward signaling now, a signal is sent in the opposite direction of the congestion. Forward signaling means now direction. That means congestion direction. Signal can be sent in a congestion direction. So the destination will be warned to the source about the other congestion. Backward signaling means now the signals can be sent. That is a signal means here it is a congestion signals. Signaling means what signaling it is sending backward? The congestion signaling. Congestion signaling can be sent to the backward. A signal is sent in the opposite direction of the congestions. That means the source is warned about the congestions. In a backward means now the source will be warned. And forward means now the destination is warned about the congestions. So it need to slow down these are the communicating devices. That means forward explicit the signaling now which is applicable for both the forward and backward. That means source station and destination station now both the stations now so it will be sending the signaling. So this the best example is a railways. In railways now whenever the disaster is occurred, railways are crashed, disaster is occurred here immediately from the particular disaster occurred at the station now sending the signals to the destination station and similarly sending the signals to the source of the stations. So this is the best example of the explicit the condition. And leaky bucket and that is a token bucket also now we can utilize for controlling the other congestions. Leaky the bucket now if we take the leaky bucket, so leaky the bucket when it is applicable now, so that means now the tokens are overflow. Here this is the bucket, in this other buckets the rate is a variable, rate is a transferring, the token transmitting rate is a variable, and outgoing that means leaking this the bucket, by leaking this the bucket here the fixed rate can be transferred. Otherwise, if it is the bucket is not leaked, so it will be overflow and the congestions will be occurred. That is a rate limiting to adding the tokens in the other bucket. Here, number of other tokens can be added. Once if it is the full, that means overloaded will be arise immediately. The bucket will be the leak. That means incoming the data. Incoming data if the tokens are available. The tokens are available here now. Here. Now the outgoing based on this token availability now splitting these the tokens dispatches to the other destinations. Tokens will be dispatches to the other destinations. And a leaky bucket. Here is the leaky bucket. Same leaky bucket means now here also just like in a leaky bucket you may transfer the you may take the general example is a with leaky water, and a leaky bucket means now the packets. With packets now we are forwarding the number of packets in a variable rate. The packets transferred are variable rate into this the bucket here. This is a leaky bucket. When the bucket is overflow, so we lost the packets. That means the congestion will be arised. So that's why the bucket will be leaked with a constant flow rate. The data rate will be very constant. The packets flow at very constant rate. So this is about the leaky the bucket. And the difference between the leaky bucket algorithm and the token bucket algorithm now if you observe, the primary the functions are traffic is a very smooth and very the traffic by outputting at a constant rate. Allowing the burst the traffic up to a certain limit, and traffic control which enforce the strict rate of the control, and which is allowing the control burst. Controlling the burst means now data flow is a variable rate of data can be flowed into the bucket. So this is a burst flowing. That burst flowing can be the control while maintaining a steady rate on a average steady rate can be maintained as a average. Token usage means so does not use the tokens. Buckets are queued, does not use the tokens, and buckets are queued. So here is now token bucket algorithm. In a token bucket algorithm now which is uses the tokens, buckets which is uses the tokens, buckets are sent only if the tokens are available. Bucket now if only the tokens are available, then only which is dispatches to the destination stations. Queue behavior in a leaky bucket the packets are queued and sent at a fixed rate. That is a leaky bucket. In token bucket also accumulated over time and to allow the burst. So this is the differences in a queue behavior. Handling burst are not allowed, but burst are allowed. Why? Because data transmission is a variable. If the sufficient tokens have been accumulated in a bucket, so that means the burst allowed is allowing the burst. Variable data will be allowed. That means the data loss is happening the data loss. Here is rate limiting. Rate limiting means suitable for shaping traffic to conform the constant data rate. It is a rate limiting. Rate limiting means now which is suitable for managing the variable rate of the traffic with burst errors. And example is a video streaming with a fixed bandwidth. This is a best example. That is a Netflix, YouTube. There is a video streaming with the fixed the bandwidth now. Videos can be the stream now. We can watch applications like here is the token bucket algorithm. The examples are the applications voice over IP. That is mobile communications or conference calls or gaming. So which are requires the bursts. And real world use case. Real world means now enforcing the contrast like the committed information rate in the several in the service level agreements. And here which is allowing the users to exceed the CAR temporarily for the bursts. Here for this congestion control, the algorithm textbooks are Data Communication and Networks, A4 region, 5th edition, and Computer Networks, yes, and US, the Tenenbaum, the 5th edition. These two textbooks are so good for the congestion control mechanism. So congestion control mechanism, when we are utilizing, the final outcome is now whenever the network overload is occurred, now then we can apply the congestion control mechanism. So these algorithms can be applied and reducing the congestion, smoothly sending the data over the network. So this is about the congestion control algorithm. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.